I quickly want to go through a couple of calculator problems on our 5th page of notes here. And so I've got x equals e to the y. I've got x equals 1, and that's going to be a vertical line. And y equals 1, about the line y equals 1. So it's about this line y equals 1, which is a horizontal line, which means this is a dx problem because it's a horizontal line. Fantastic? All right, now we need to draw the rest of this stuff. So, just so you know, this right here, if I have it in terms of x. In terms of y, this is y equals the natural log of x. All right, so I want to go ahead and graph that. There we go, that is graphed. I happen to know that this crosses here at the 0.10 because the natural log of 1 is 0. Let's see. So that is also a boundary. So let me draw that in. X equals 1. So the area that's bound by all of this is this area right here. All right, and we are going to rotate around this line y equals 1. So I hope you can see this is a disk problem, not even a washer problem. So our radius, we only have the 1, is right here. Capital R, little r, doesn't matter because you only have the 1. We need to know this point right here. So what we're going to do is we're going to plug 1 in for y. We can do it actually here. It's easier. So if I plug 1 in for y, I have x equals e to the 1, which equals e. And so this is the point E1. Pretty cool? Yeah, awesome. So my outer radius here is this distance 1 minus my distance from here to here, because this distance is 1 minus this, which is my function value. So this is going to be 1 minus the natural log of x. There is no inner radius. This is a disk method. Makes sense there? All right. And this is some calculator work. Volume equals pi times the integral. Since we have dx, we want x values. So this is going to go from 1 to e of r squared. So this is 1 minus ln x quantity squared dx, which you can't integrate anyways. Plug that into your calculator. Pause the video now, do it, and see if you get 1.372. All right, let's do another one. So let's go down here to the next one. This happens to be a vertical line that we are revolving around. So this is going to be a dy problem. All right, and so I've got y equals the cube root of x, which I happen to know looks like this. Y equals 0, which is right here, and x equals 8. About the line, x equals 8. So this right here is x equals 8, and the area that we're going to rotate, and I hope you can see because we touch the line we're revolving around, that this is a disk problem. So interestingly enough, I need to know what this point is here. So I am going to take my formula. I have cube root of x equals 8. All right, I happen to know just by looking at that, that means x equals cube root of x equals, oh, I did this backwards. Let me erase this. Not y. We got to switch it to y first. if you have y equals the cube root of x, then you have, and x is 8, you have y equals the cube root of 8, which is 2. So this is the point 8, 2. There we go. Which means x equals y cubed, because we need our function in terms of y, because we're doing dy. So I've got the point 8, 2. Let's do a little, there's where we're revolving around. Let's write in our radius. When you're calculating out what your radius can be, remember, right minus left. So our radius, mark that right there, our radius there is 8 minus y to the third. We don't have an inner radius because this is a disk method. Let's go ahead and write our integral, and we'll use our calculator. Volume equals pi times the integral from 0 to 2. It's a dy, so we need y values, not x values, of 8 minus y to the third quantity squared dy. Take a pause on the video, plug this in your calculator, check and see what you get. Hopefully you are going to get the same thing I got, which is 258.508. All right, one last problem, and would you believe it? Okay, let's stop for a sec. After this problem, this is the last problem of instruction of new material in the entire APCalc course. From this point on, all we do is review. Review, review, review. This is it. This is the last piece of instruction. Okay, y equals 2 times the square root of x. Well, I know what that looks like. That looks like this. Okay, and y equals 6, which I guess is this, and the y-axis. Oh, that's this. Okay. About the line. All right, so that makes sense. This is our area. You would think I'm just discovering this for the first time, that I didn't just do the problem about 2 hours ago. All right, so this is our axis of revolution. We need to find this point. This is the point where y equals 6. Y equals 2 square roots of x, so 2 square roots of x equals 6. Divided by 2 means square root of x equals 3, therefore x equals 9. So this is the point 9, 6. All right. This is a horizontal axis that we're revolving around. So this is a dx problem. So we needed that x value. All right. We need our radius. Let's draw that in there. There's our radius. And our radius, remember, top minus bottom. So r equals 6 minus the bottom, which is 2 square roots of x. No inner radius because this is a disk problem. Volume equals pi times the integral. We need x values, so this is 0 to 9 of 6 minus 2 square roots of x, quantity squared, dx. Take a minute, pause the video, put that in your calculator, and then come back and see how you did. Hopefully you got 169.646.